All right, here we go. Algebra 1. We are starting Chapter 9, identifying quadratic functions. So you have now spent a lot of time working with linear functions. What graph do you get when you have a linear function? I hope you said line. There's nothing else I've taught you. It's that you get a line when you have a linear function. So the standard form for that is ax plus by equals c. But oftentimes we have been using y equals mx plus b, where m is our slope and b is our y-intercept. Okay, that is our slope-intercept form. This is our standard form. We also talked about, so this is all review, we've talked about how do you take a set of coordinates and figure out if they would make a linear function. Well, you can look to see if they're linear, a function, by simply making sure there's a one-to-one correspondence, right? So we can look and say, okay, the 2 only maps to a 4, the 5 to a 3, the 8 to a 2. Yep, my x's are all different. So we're good. It's definitely a function. But now to check for linear, we have to put it in our little chart here. So do you remember this? We list our 2, 4, 5, 3, do this with me, 8, 2, and 11, 1. And then you're looking to see if there's a consistent increase or decrease pattern. Not multiplication, but adding and subtracting. Difference. So let's see, this one you add 3, add 3, add 3. So we're good on that side. Let's check the other side. Minus 1, minus 1, minus 1. Check. Yes. It is linear because the first difference is the same. That is called the first difference. So that is all review. We have done that before, and we spent a lot of time on that kind of stuff. Now we're switching gears. We are now moving into quadratic functions. Quadratic. So do you know what kind of graph you get for a quadratic function? Well, you get what's called a parabola. Spell it correctly. And when you graph it, it has a U shape. And it could go down too. So it can go either way. And the standard form for a quadratic is right here. So highlight that. When you look at the two different forms, I'm just going to sneak that other one down here. What do you notice? What's different? What do we have in here that we don't have up here? Well, I hope you're noticing we have an x squared here. Then there's an x, then there's a number. Up here we just have the x, and then you could look at it this way because this is the one where this y is on this side, so it might be more comparable. So you have something times x plus a number, something times x plus a number. Okay? What this is the part that is not in those. Anything raised to the second power. Okay? So we can, again, if you're trying to say and figure out, is this a quadratic function, you're going to start it just like we did up here for the linear. So here's a set of coordinates. Is it a function at all? Well, let's check our x's. Yep. So I don't have to do any further check then to notice all the x's are different. Now I'm going to put them in here. So go ahead and do this with me. And then we're going to check the left side like normal. Oh, wait a minute, that's a plus 1. I'm making a mistake. From here to here is plus 1, and from here to here is a plus 1, and plus 1. So check, the x's are good. And let's check the y and see if it could, maybe it's a linear. Let's see. That's down 3, that's down 1, that's up 1, and that's up 3. So it's definitely not linear. Okay? If these were the same, we'd have a linear. But now what we're going to do is we are going to do that exact same thing again with these numbers. This is called the second difference. This was the first difference. Now we're going to see what happens here. When you go from -3 to -1, we add 2. When you go from -1 to +1, we add 2. +1 to +3, we add 2. This is called the second difference. Okay, this was the first difference. So when the second difference is the same like that, where you're adding or subtracting the number, then yes, it is a quadratic. Not a linear. It can't be both. Okay, it can't be curved like this and a line at the same time. So it's never going to work. If you get a linear here, you stop. It's linear. If you don't, you check it again and see if it's quadratic. Okay, now sometimes you can tell if it's a quadratic by looking at the equation. Okay, so remember what we noticed when we looked at these equations? This just had an x term, or it could just have the number even. But the difference is with a quadratic, you'll always have this x squared in there. So let's look down at those example 3 and 4. Sometimes you have to get them into the y equals that form, and this falls right into this form, doesn't it? And what is that the form for? Is that a quadratic or a line? That's right, that's a linear. So this is a linear equation, or linear function, I should say. We've been using that. And when you look over here, you can get the y alone, like they do up here, right, to see if it sets up like this. But I can tell before I even do this that it's going to be quadratic. And I'm curious if you can tell what I'm seeing that tells us that. It's this term right here. You have an x squared. That's what tells you it's a quadratic. Okay, so this is a little bit, this is like 3 pages, but it's kind of not real in-depth stuff. It's more different terminology and understanding of things. This is the first thing you need to understand, is how to tell if you have a quadratic. And there were 3 different ways we talked about. So if you're given points, you set them up in your XY chart and you check the second difference. If you're given equations, you're looking to see if it has an x squared. If it does, it's going to be a quadratic. Okay? Next. All right, example 2 now. Let's see what the next task is. It's to use a table of values to graph each quadratic. Okay, so we're going to now graph. And this is where it becomes really important, because of that square, that we use 5 numbers, and we're going to want to use negatives. So in general, you start with those. And if you don't get the picture you know you should get, you can do more positives or more negatives. So as I've always said, set it up with everything but your x, and let's see what we get. So we're going to put the -2 in there. So what do you do first? Do you multiply or do you do powers? That's right, you do powers. So what's -2 to the second power? -2 times -2 is 4. Times the 3 is 12. Then we're going to go to the next one. We're going to go to -1. -1 squared is 1. Times 3 is 3. You guys can go ahead, and if you can do these, go ahead and do them on your own, then you can check them with mine. Zero squared is 0, times 3 is 0. One squared is 1, times 3 is 3. And 2 squared is 4, times 3 is 12. So you see the pattern that kind of happens with a parabola here. So let's graph those. Obviously we're doing 12s here, so I'm not going to go by 1s. I'm going to go by 2s. 2, 4, 6, 8, 10, and 12 is the highest. These I'm still going to do 1, 2, 3, 4. All right, so negative 2, 12. So negative 2 and 12 would be up here. Negative 1, 3. Negative 1, and then 3 would be between the 2 and the 4. 0, 0. 1, 3. Again, between the 2 and 4. And 2, 12. That is not a V. Do not draw a V. No matter what you do, don't draw a V, because look, there's no way that these line up on the same line. It doesn't happen. They do not line up on the same line. So this is where we get the U, and if I can do it, you can do it. So we're going to try to draw our curve in here the best that we can to get our parabola. So try to make a curve down here, because that's what a parabola is. Okay, let's try another one. So why don't you guys pause the video and try it. Y equals negative 4. Set it up there. Actually, all right, let's use this again. What did we say to use? Negative 2, negative 1, 0, 1, and 2. Let's put them in there. Put the negative 2 in there. When you square that, you get 4. 4 times negative 4 is negative 16. Put a negative 1 in there. Negative 1 squared is 1 times negative 4 is negative 4. Put a 0 in there. 0 squared is 0 times that is 0. Put a 1 in there. 1 squared is 1 times negative 4 is negative 4. You see the pattern. Put a 2 in there. 2 squared is 4 times negative 4 is negative 16. Okay, then we're going to graph, and again, going to go by 2's here, but this time in the negatives. Negative 2, negative 16, all the way down here. Negative 1, negative 4, 0, 0, 1, negative 4, and 2, negative 16. So again, we're going to do our best to draw a nice curved, and put your arrows on the end. So it's just like as if you're doing a linear where you still set up the same thing. It's just this time you got to make sure to have the negatives in there, because when you're squaring an x, then it flips it depending on if you have negative or positives. So, all right, now let's move on to the next thing. I rewrote this equation on this side because we're going to learn some things. Just like when you had on this other page, when you had y equals mx plus b, you were able to look at it, right, and know that the m was your slope and the b was where it hits the y-axis. Well, there's things you can tell from a quadratic by looking at it too. So we're just going to start learning some of those things today. We can tell what direction. Do you notice how this opens up and this opens down? This opens up and this opens down. You can tell that when you look at this a right there, the number before the x squared. When that number is bigger than 0. So let's look up here. Is it bigger than 0? Yes. Okay. Is that bigger than 0? No. So basically what happens is you end up having a positive value here, and, oopsie, you're going to have a positive value here. That's going to go up. If you have a negative value, if a is less than 0, which would basically mean it's negative, then it's going to curve down. Okay, so those, we're going to be looking for those, and you're going to be telling me upward or downward. Question is, what if it's 0? That number's not there. We've got every other number in the real world except for 0. Why wouldn't they have included 0 here? What happens if that's 0? Well, it doesn't matter what this is. What's 0 times anything? 0. So that drops out, and you're left with y equals bx plus c. You're back to having just a line. You've lost your x squared term. So that's why we don't include that, because you can't have a quadratic and have the a be 0. So let's practice. Tell whether the graph of each quadratic function opens upward or downward. So in order to determine that, you do have to have it written in the right form, which basically means you are solving for y. So go ahead and look at A and think about how would you solve that for y. You're going to draw your line, you're going to locate your variable, and we're going to have to get rid of that negative 1/4 x squared. And how are we going to do that? We are going to add 1/4 x squared. That's gone. I'm left with y equals, and x squared, x3, none of those are like terms. So I'm just going to write 1/4 x squared and then rewrite these terms, plus x minus 3. So take a look at that. When I add a whole term, because I'm not going to add just the fourth, this is a monomial. This is all together. So I have to move it all together. So when I do that, I can now look at what is before the x squared. It's 1/4. Is that a positive? Is that something bigger than 0? Or is it a negative? Is it something less than 0? Obviously, it's positive, right? So we know then that this graph is going to open upward. Because a is greater than 0. 1/4 is bigger than 0. Okay, why don't you guys try that one. See if you can get this all set up. It's almost in the right form. You just got to rewrite that right side, don't you? So we'll just, the y is here, and that's fine. I'm just going to put this term first, so don't forget the sign before it. That goes with it. The sign before the 5x is a plus, positive. So now, what is the a? The a was the number before it. That's what we're looking at. What's the number before it? Negative 3. Obviously, it's a negative number. So therefore, that is our a. That is less than 0. So that tells you, look directly above. It's going to turn downward. Because a is less than 0. Negative 3 is less than 0. Okay, so that's another thing you're going to do. So let's review again. So first the first thing on the notes was trying to figure out if you had a quadratic. The next thing was, how do you graph a quadratic? Now we were talking about how to determine if it opens up or down. And then I think we just have one more thing to do. Oh yeah, the minimum, maximum. I guess we have a couple things left to do. All right, so let's flip this over. and take a look at the top. We're going to talk about these different parts of a parabola. The vertex on this is it's like the tip of the parabola. So it's right there. That is your vertex. It's a coordinate. A vertex is a coordinate. So you've got to figure out, what is that coordinate? It's -1, -1. That's what vertex means. The next thing is the minimum or maximum. And I just dropped my... Honestly, where the heck did it go? I'm going to fall on the ground now. Oh my goodness sakes alive. It's like a jungle gym. I can't get... Oh well. Okay, so the yellow marker's gone now. But hey, have no fear. I got another one. Okay. So we're going to talk now about minimum and maximum, but I don't want another yellow. I want pink. I got that too. So we're going to talk about minimum or maximum. So when you look at that vertex, we're looking at this right here. Is that point a minimum of the whole graph, or is it the maximum of the whole graph? So remember, a parabola has infinitely many points all along it. Is that the smallest or the largest point? You're right, it's the smallest. It's the lowest on there. So it is called a minimum. So you won't do both these. You're just going to circle which one is right. It's minimum. And then you're going to tell what it is. How do you know what it is? Just like I drew that line. Where does it cross the y-axis? At -1. That's right. So that is my minimum, -1. You don't put a coordinate for that. You just take and extend that over and see where does it cross. Okay, before I do these two, let's go over to this side and talk about it. Okay, do you see where the vertex is? Do you see that coordinate? It's right there. And can you tell me what it is? Well, you don't go anywhere here, and 1, 2, 3, 4, 5 up. So it's the point 0, 5. Vertex is always a coordinate. Now, is that point the minimum of the graph or the maximum? Yes, it is the maximum. I hope you guys were saying maximum. It's the top of the graph. It's the maximum. Now, what is the maximum? What's the number? Right there. It crosses right there. What is that? That's 5. But I don't put the coordinate again. I just put 5. I just put where it's hitting that y-axis if I were to extend a line over. Okay. So now we're going to talk about domain and range. So do you remember what domain and range were? Domain was, or is, I should say, the x values, and range is the y values. So when you're figuring this out and you need the domain, we're talking about holding our pencil vertical and going across and seeing where does it hit the graph. Slightly tricky because you get the impression that this is going to like go straight up, but it actually doesn't. It just ever so slightly edges outward as it goes up, forever and ever. So no matter where you put your pencil way off the page on this x-axis, it's going to hit this graph. It may be way off the page and all the way forward 2 miles, but it's going to hit it somewhere. Okay, because remember the parabola goes forever. So the nice thing about parabolas is that the domain a lot of times, almost always, is that, which means what? All real numbers, right? It's all real numbers. And then we talk about the y values. Remember, we turn our ruler or whatever, and we're trying to go this way. So if we start at the bottom, we go up. When do we hit the graph? Right there. What is that? -1. And then do we ever stop hitting the graph? No, because the arrows tell me it keeps going forever right off the page. Okay, so we have infinitely many points. I can't just list a bunch of points down. I need to list an infinite amount of points. And the best way to list an infinite amount of points is with inequalities, greater than and less than signs. So we know that it started at, we're going to use y because it's range. Y is greater, because it's going up, or equal to, right here, -1. It's all the way up. It doesn't matter. Starts here. If I go down here, no, never touches it. But it starts here, and then forever up, it'll touch it. So look over here now. Can you guys talk about the domain? What do you know? Yep, it's all real numbers. It doesn't matter where I hold my pen. Considering this goes forever, my pen would hit it if it, of course, went forever as well. If I drew a line through. Now the range, well, I'm not going to start down here because if you notice, these lines are going down there. So this is going forever. So I'm actually going to start up here and go down. And where does it hit? Right there. Okay, that's where it hits. And every time when I go down, it's always hitting the graph, isn't it? Forever and ever. So it's going to be, y is what? Is it less than or greater than? Less than or equal to this. What is that? 1, 2, 3, 4, 5. All right, a lot going on here. So let's practice a little bit now. This is it for the new stuff. We're just practicing on the rest of this page. So I want you guys first to do the vertex. Can you look at these two graphs and write the vertex? You say, what's the vertex? Well, look above. Use your resources. Look at the top of the page. What was the vertex up there? Now try to replicate it on these two. Okay, so when you're doing it, or let's see, 1, 2, 3. It's right here, and this goes up 2. So this coordinate is -3, 2. Hopefully you had that. That's the vertex right there. And then here's the vertex here. And that coordinate looks like it's 1, 2, 5. Is that, now I want you, don't say it out loud, minimum or maximum? Circle it. Is that a minimum or maximum? Circle it. Now find out what the minimum is. What's the number here and what's the number here? See if you can do it. Okay, so hopefully you noticed it's a minimum. It's the lowest point and it's at 2. Hopefully you notice this is at the maximum point and it's at a 5. Just for fun, let's do the domain and the range of each of these. Forgot what domain and range is? Look above. Domain is your x values. It's holding your pen like this. What's the domain for this? Yep, all real numbers. What's your domain for this? All real numbers. Now the range is an infinite amount of points, so you're going to use an inequality here. So you hold your pen this way, or your ruler, or whatever it is you're going to use. Y is, what is that, 2? Greater than or equal to 2. Y is less than or equal to 5. Okay, what's the domain of this one? Yes, you're catching on. All real numbers. What's the range? Y is less than or equal to, what number is that? -3. You know what I'm going to ask, right? Yeah. Do the vertex and do the min-max. Did you get -5, -3? -5, -3 for that vertex. And that is the maximum at -3. Everything else is below it. All right, sounds good. I want to show you something super cool I have here at home. That is my holy water from Lourdes that Mrs. Sieben gave me. Isn't that thoughtful? So I have that at home here. So whenever I need a little extra blessing, I sign myself with the holy water. So, all right, sounds good. We'll see you tomorrow.